Okay, let us see how you handle this question now. For it is from complex numbers. It's very easy. Of course, we also covered complex numbers in details, a full topic. You can go to the playlist and then search through complex numbers. It's there. Okay, so you can go get into my channel, swipe to the left, swipe to the to the right, then you read playlists, then you can go through the other complex numbers and details. Now these are just parts of questions we can expect from there. So it says if n is a variable and z is equal to that, show that the locus of z is a straight line. Then b, determine the minimum value of z. So we can determine the minimum value in many ways, but let us first know the locus is z. Okay, the hint here is if we have two equal complex numbers, so this is a complex number, is equal to this. We said if two complex numbers are equal, it means that their real parts are equal and then their imaginary parts are equal. What do we mean by the imaginary part? The imaginary part is a coefficient of I. So this d is now the imaginary part is equal to y if these two are equal. And also if we have z given by this, to get the modulus of a complex number, we square the real part plus the square of the imaginary part. Our imaginary part is y, not iy. Our imaginary part is y. So it's that if I square both sides, I'll be having that. These are the things we are going to use onto this number. So the case is, now if I have this number, this is the complex number they are giving me. If I multiply through, this is what I get. So I let z be equal to x plus iy, and I put it there. There now x. Minus 3n. And then we say, if I have two equal complex numbers, it means that their real parts are equal and imaginary parts are equal. So, in simple terms, we are compare linked. So, it means that now my x is going to be equal to 4n, and now the imaginary here is y equal to 2. The imaginary side is this, which is 3 minus 3n. The I is telling us the imaginary parts. So from here, you see that this is the line. I need to bring in the x. So I'm going to remove this n from there. So that if from here my n is going to be x over 4. And if I put there, you can help this start from my y equal to 3 minus 3n, and my y will be 3 minus 3 into now x over 4. Which when we simplify, anyway, you can leave it there as y equal to 2, negative 3x over 4, then plus 3. So how do we describe the line? So you need to describe, you can say, the locus is a line. Now we determine the gradient. With the gradient, you see that, or is this giving us the gradient? Negative 3 over 4. And the intercept. Is the intercept. This is always giving us the intercept. Intercept 3 from y equal to mx plus c. This one is always our gradient. This one is always our intercept. On condition, this coefficient is 1. So that's how we describe that. So you get your marks from there. Then part B, they want us to get the minimum value of that. You can use the operating square methods, or we can use the idea of differentiation. So the idea of differentiation is better because it's short, but in operating squares, people make mistakes. So let me go with the idea of differentiation. So from here, when I write this back, you start line z is equal to 4n plus I into 3 minus 3n. So they want me to get the modulus. So how do you get the modulus? You square the imaginary, then you square the real part. So from here, my z is going to be now the square root of, I square the real part, then plus I square the imaginary. This is my imaginary. The whole of this, which is 3 Never introduce, never put in I here. I is just to show you the imaginary part. So if I square both sides, it's that my z squared is going to be equal to 2. When you multiply here, we have 16n squared plus 9 minus, this is 9 times 2, which is 18n, then plus, when you square this, you get 9 squared. Simplifying that, moduli squared is going to be, this is going to be 25 n squared minus 18n, then plus 9. To determine the minimum value, then you differentiate this with respect to n. So now differentiate this with respect to n because this is a function of z and n. I'm now differentiating this. So now when I differentiate this, I lower this power. Then of course I reduce the power by 1, this one here. So I'm going to differentiate this z squared equal to 2. I differentiate also this with respect to n. 25 n squared minus 18n plus 9. I differentiate this, I get 2 modulus of z. When you differentiate this, is equaling to when I differentiate this, I get 2 the n 2. Then when I differentiate this, I get, when you apply there, I get 50 n minus 18. So if I divide this through by 2, so that my the n is going to be divided by 2, get 25n minus 9. But you know, for minimum value, whereas our the n should be equal to 0. And equating now to 9 to 0, so that our n is going to be 9 over 25. So this is the value of n that is going to give us the minimum value. Then I come back and I substitute it there again. So from here, I think we can end this. We are going now we match this, but we are going to substitute in there. So from z, n equal to the square root of, when you square this one, we're getting the whole of this 25 n squared minus 18n plus 9. Then we simplify this 2, the square root of 25 into n, which is 9 over 25, the whole square, minus 18 into 9 over 25, then plus 9. And so when you simplify this, so that here you're going to be having the square root of, this is going to be 81, then 1 is going to cancel that, over 25. And then when you simplify there, we have, let me get and simplify it once. Okay, so this one is going to give me minus, now it's not the LCM is this. So I get here 162 over 25 plus 9. And you see that I can ably get my z as, so that my LCM is going to be 25. So 25, and I have 81 minus 162 plus, this time is 25, getting 225. Then when I simplify, it becomes the square root of 144 over 25. And so my z, the minimum value of z is going to be 12 over 5, which we can give us 2.4. That is going to be our minimum value. or you can use the idea of completing squares if you want. Here we are putting, because this is the value of n at the minimum. So that's why I'm putting z min. When I put in that value, I'm getting z min, the minimum value of that z. That's how we handle it. So you go through the idea of using completing squares. You know, in the complete squares, if a is positive, the coefficient of x plus b, the whole squared, if it's positive, then the other becomes minimum. That value after completing squares. So use that idea and see. Otherwise, I wish you well. That's the number from complex numbers.